Okay, it's given that dy by dx equals this. Now, okay, this is e here. Okay, this is the exponential function e. Now the question says solve this differential equation. Now, since it contains dy by dx, it contains differentiation. This is called a differential equation. Now, solving a differential equation is simply means if dy by dx equals this, then what's y going to equal? The question is simply asking this. Solving a differential equation means if dy by dx equals this, then what's y gonna be? We need to find this. So first of all, let's start off with a simple example. Okay, let's say there's a curve, and at any point the gradient of the curve is given by dy by dx equals 3x squared. Okay, so now the question is, that's a question asked many times in the AS level. What's y going to equal? If dy by dx equals this, then what's the equation of the curve? So that's what's y. Y is simply integration of this, and this is 3x cubed by 3. 3 cancel, and this gives x cubed plus c. Okay, so look here, dy by dx equals this, and from we have transformed this into a form where y equals, we have removed the d by dx and just obtained y. This is what we call solving a differential equation. If dy by dx equals this, then what's y gonna equal? That's the solving. Now how did we do this? Now, yeah, we integrated, obviously we integrated, but how did we integrate? If we integrate this directly, let's say here and here, can this be done? Look, what's the integration of dy by dx? And look, as integration of 3x squared. There's no with respect to x, so this cannot be integrated at all. So first of all, we need to write this differential equation into a more simpler form. That is, we need to separate the variables. We need to put y on one side and x on the other. So let's put all the y on one side. This is y, dy, because there's no y, there's only dy. And let's put all the x on the other side. So 3x squared and dx. Look here, put all the x and dx on one side and put all the y and dy on the other side. Since there's no y, this is simply dy. Now we can integrate this. Now what's this? This integration of 1 dy. Integration of 1 respect to y is simply y, and this is x cubed plus c. Yeah, so this is how we basically solve a differential equation. Separate the variables x and dx on one side, y and dy on the other side, integrate this, and you get the equation. Okay, so but remember that dy and dx must be at the top. They must not be on the denominator, because if they are like this, then what's this gonna be? This cannot be solved. So they must be at the numerator, not at the denominator. So basically we have to do the same thing here. So let's do it. Separate the variables, put all the y and dy on one side. So this is going to be 1 by y dy. Yeah, here's y, 1 by y equals 6 e to the power 3x over 2 plus e to the power 3x dx. Okay, y and dy on one side, x and dx on other side. So let's integrate this. So what's the integration now? All that left is to find the integrals. What's the integration of 1 by y? Before, I'll just ask you, what do we mean by integration? Okay, what's the integration of x? X squared by 2 plus a constant which I'll not write here. And what's the differentiation of x squared by 2? The differentiation is x. Look here, integration of something will give us something, and if we differentiate that something, we will get the original function. Okay, integration of x gives x squared by 2, and if we differentiate x squared by 2 we will get the original function. So integration of something, so what's the integration of x is another way of saying the differentiation of what will give x. That's the integration of x. So that's why integration is called antiderivative. Okay, let's not delve there. So okay, let's see. So what's the integration of 1 by y gonna be? So this is simply integration of 1 by y is another way of saying the differentiation of what will give 1 by y. Integral of 1 by y gives something, the differentiation of that something is 1 by y. So integral of 1 by y is another way of saying the differentiation of what is 1 by y. So what's the differentiation? So the differentiation of what is 1 by y, that's the integral of 1 by y. So what is that what? We know dy of ln y is 1 by y. Therefore the integration of therefore the differentiation of ln y is 1 by y, and we know that the integral of 1 by y is something that when differentiated will give 1 by y. Okay, let's just make a conclusion. Integral of 1 by y, another way of saying the differentiation of what will give 1 by y, and as you can see the differentiation of ln y gives 1 by y. Therefore the integral of 1 by y is ln y. Now what to do about this here? What to do about this? You cannot split this into partial fraction or something, and you may be guessing, oh, integration by parts or substitution, but look, this is in a very familiar form. That is, it is in the form of there's a function in the denominator and its derivative is on the numerator. So if there's a function at the denominator and its derivative is on the at the numerator, then the integral of that is gonna give ln fx plus a constant. So actually it's modulus, but we don't need that for now. So look, remember this result, just keep this in mind, and look here, this is very familiar to this. So what's the derivative of, okay, this is fx, yeah, fx is this. What's the derivative of fx? The derivative of 2 plus 3 e to the power 3x is 3 e to the power 3x. We obtained this using the chain rule. Now look here, so fx is 2 plus e to the 3x, and f dash x, the derivative is 3 e to the power 3x. Well, look here, here's 6. So what are we missing? We are missing 2 here. Yeah, we are missing 2 here. So if we put 2 here, then look here, 2 times the derivative divided by the function, that is 2 times 3 e to the power 3x over 2 plus e to the power 3x is the same as this. Therefore this is equal to this, and this is equal to what? 2 times, look, derivative over function is ln fx. So derivative, so 2 times the derivative over the function is 2 times the ln 2 plus e to the power 3x. You get what I'm saying? Look here, it was 3, yeah, look, the derivative, look, this is fx and f dash x is 3 to the power 3x. So this by this is this, and this by this is ln fx. Therefore this is ln 2 plus e to the power 3x, but there's 6 here. So in order to make this equal to 6, we need to put 2 here. Therefore and this is equal to ln 2 plus e to the power 3x, and if there's 2 in front, it's going to be 2. So yeah, remember this. Therefore, using that rule, this is going to be 2 ln 2 plus e to the power 3x. And don't forget, the limits are not given, therefore we need a constant. Now the constant you may call c, but I prefer that the constant I will call ln c, because if c is a constant, then ln c is also a constant. And why I chose ln c, you will see in a moment, because it's easier to work with, because here ln all are in ln. So now we need to find the constant ln. Now how do we do that? The constant, we need to find the constant ln c. How do we do this? We have given some values. It says that y equals 36 when x equals 0. So if we put these values here, we can find the constant ln c. Now notice that we need to find the constant. The constant is ln c. So we need to find ln c, not c. So this is ln y, ln 36, 2 ln 2 plus e to the power 3 times 0, that's 2 plus 1, ln 3 equals plus ln c. Now this is what? ln 3 squared. Remember that this and this are the same thing. Yeah, the power, the number as the product, the number as the product will become the power plus ln c, and therefore ln c equals ln 36 minus ln 9, and ln minus, look, minus, this is ln 36 over 9, that is ln 4. Therefore ln c is ln 4. Now let's substitute here. Plus, what's the constant? Constant ln c is ln 4. Okay, so now we need to isolate y. Okay, so let's just do this. First of all, let's simplify this more. This is ln 2 plus e to the power 3x. Look, the number as a product will become the power plus ln 4. Okay, and ln a plus ln b is ln ab, so this is ln 4. I'm assuming that you know all the logarithmic rules, so this is going to be this, ln y equals this. Okay, now in order to cancel the ln, we take e to the both sides, and look, ln and e, they are inverse functions of each other, so this is going to be y equals 4 2 plus e to the power 3x whole squared. Okay, and this is the solution. So the question was, if solve this differential equation, and as I already said, it's simply asking if dy by dx equals this, then what's y gonna be? That y equals 4 2 plus e to the 3x whole squared. Now to do this, just remember, separate the variables and integrate. That's the basic thing. Now you must know how to integrate these terms, because if you don't know how to integrate, you will not be able to do. And you also need to know the properties of the logarithmic functions. So let's look here. Integrate, this is ln y, because derivative of ln y is this, and this is in the form. Look, you can check the derivative of this is 1 by 2 plus e to the power 3x into 3 e to the power 3x, there's 2, so this is the same, and there's constant here, just put the values, use logarithmic functions. Look, 2 ln 3 is ln 3 squared, a, okay, ln a to the power n is n ln a, yeah, you just use that rule. Ln a minus ln b is ln a, and ln a plus ln b is ln ab. So that's it. I hope that helped. Thank you.